Hi, I am Dr. Yogesh Sharma, Assistant Professor, Ramgarhia College of Education, Phagwara. Today our topic is SPSS for Associational Inferential Statistics. This is last of the series SPSS for data analysis. By the end of this video, you will be able to tell assumptions for applying Pearson's product movement correlation coefficient test, able to get scatter plot in SPSS. You will be able to apply Pearson's product movement correlation coefficient in SPSS. You will be able to apply Spearman's rho in SPSS. You will be able to apply partial correlation test in SPSS, and you will be able to conduct regression analysis in SPSS. In this video, we will study the procedures for studying association between variables. We are going to start with bivariate correlation. The first measure of bivariate correlation coefficient that we are considering is Pearson's product movement correlation coefficient. The value of Pearson's R lie between -1 to +1. -1 shows perfect negative correlation, 0 shows no correlation, and +1 shows perfect positive correlation. Suppose our research question is, what is association between creativity and academic achievement? Or in terms of null hypothesis, we can say there is no significant correlation between creativity and academic achievement of school students. Data entry for bivariate correlation, that is Pearson's R, is straightforward, as data is entered into two separate columns. You can see here in one column data for creativity and another column data for academic achievement. The Pearson's R is most commonly used measure of relationship. The Pearson's R is used when the assumptions are met, that is, data is not skewed, the level of measurement is at interval or ratio scales, and the two variables are linearly correlated. So before applying Pearson's R, we must check that the two variables have linear relationship. For checking this, we can develop scatter plot in SPSS. We will go to the graphs. Then there is a legacy dialog. Then move to the scatter dot. Click on that. Now click on the simple scatter. Define. Put creativity in the x-axis and academic achievement in the y-axis. Usually we put dependent variable in the y-axis. Click on the titles. You can give name here, correlation between creativity and academic achievement. Click on continue, then click on OK. You will see here is a graph, scatter plot. Now we will double click on this and the chart editor window will open. Here is a chart editor window. We will click on elements and we will go to the fit line at a total. Just check that the button against linear is checked. Close this and you will see that there is a line. This line shows that the scatter plot shows the best fit for a straight linear regression line, and R square is very high. It is equal to 0.968, so R will be 0.98. So there is no problem of linear relationship between two variables. We can move further. Now for Pearson's R, click on Analyze, go to Correlate, then to Bivariate, then click on Creativity and Achievement, select both variables, move those variables to the variables box, click on Options, there will be a means and standard deviation box, click on that, continue, and here you can see there are three options: Pearson's, Kendall's Tau and Spearman. For time being we will check on Pearson only, click on OK, and in the viewer, SPSS viewer, you can see the output. Now suppose data is skewed, that is, it is not normally distributed. The two variables are not linearly related. The data is at ordinal level. Then in this case we will make use of Spearman's rho instead of Pearson's R. We will take same data, and for the time being we suppose that the data of creativity and academic achievement does not meet the assumptions. We will click on Analyze, go to Correlate, then Bivariate, and now instead of Pearson we will click at Spearman, and there will be the output. This is 0.991. You can find that this correlation is little bit less than the correlation we find in case of Pearson's R. SPSS also allows us to find multiple correlations at the same time. Suppose we want to study the correlation between creativity and academic achievement. We also want to study the correlation between mathematical creativity and mathematics achievement. We want to study the correlation between mathematical creativity and attitude towards mathematics. For this we will go to Analyze, we will move to the Correlate, then Bivariate, and then we will send mathematical creativity also in the box. These two have less data, so we will not send here. Mathematics, that we will do some other time. And here we will click on OK, and here we will get the simultaneous correlations, the multiple correlations at the same time. Now we will study partial correlation in SPSS. In partial correlation, we study the correlation between two variables by partialing out the effect of other variable or variables. Suppose our research question is to study the correlation between creativity and intelligence by partialing out the influence of academic achievement. So we want to study the relationship between creativity and intelligence, but we need to, or we want to partial out the effect of academic achievement. The data is again very straightforward. There are three columns, one for creativity, one for academic achievement, and one for intelligence. We will click on Analyze, move to Correlate. Now we will move to the partial. Click on Partial. Now we will move variables creativity and intelligence in variables box, and as we need to control for academic achievement, we will send it into the controlling for boxes. Click on Options, click on Mean and Standard Deviations, click on Continue, and then OK. You will get the output for correlation coefficient, and it is minus 0.412, which is significant at 0.080, so it is not significant at 0.05 level. Next is simple linear regression. This helps in predicting one variable on the basis of another. The research question is, can we predict mathematical creativity from mathematics achievement in secondary schools? We have only two variables. One is mathematical creativity and another is mathematics achievement. We need to predict mathematical creativity on the basis of mathematics achievement scores. Click on Analyze, then there is Regression, then move to the Linear. Now click Mathematical Creativity and move it into the Dependent list, and here we have Mathematics Achievement. Move it into the Independent box. Here the method will be enter. There will be some other methods also: enter, stepwise, remove, backward and forward, but we will make use of enter only for the time being. Click on statistics, estimate, then just continue. We will make use of these in the multiple regression, and click on OK. So there will be the output. You can see the R is 0.036 and R square is 0.001, which is negligible, and also this is not a significant. So none of the variables, in fact we have only one variable, mathematics achievement. This is not significant in predicting mathematical creativity. Moving further from linear regression to multiple regression, the multiple regression tells us how well a set of variables can predict a dependent variable. It tells us which variable is best predictor. It tells us whether a variable is able to predict when effect of others are controlled. Multiple regression has three methods: hierarchical, that's blockwise entry. Here the order of predictors is decided by the researcher. The predictors are ordered on the basis of their importance derived from the theory. Second method is enter, or it is a forced entry, as all the predictors are entered simultaneously. And third is stepwise methods. Under stepwise we have three procedures: forward selection, backward selection and stepwise selection. Here predictors are entered on the basis of mathematical criterion. Multiple regression has certain assumptions. That is, the sample size should be large. It should be large in such a way that n must be greater than 50 plus 8m, where m is number of independent variables. So if there are 5 variables, n must be greater than 90. There should not be any problem of multicollinearity. There should not be any outliers. There should be no problem of normality as well as linearity. Now we will try to find the answers of some questions with multiple regression. The questions are: how well does mathematics anxiety, attitude towards mathematics, and mathematics aptitude predict achievement in mathematics? And which is best predictor of achievement in mathematics? Aptitude, anxiety or attitude? Here it is attitude towards mathematics, mathematics anxiety and mathematical aptitude, and we want to find some questions answers with multiple regression. We will click on analyze, click on regression, move to linear, click on linear, press reset button. Now which is our dependent variable? Our dependent variable is here achievement in mathematics or mathematics achievement. We will move it into the dependent box. We will move the independent variables, 3 independent variables in independent box, and we will click on plots, Z pressed on Y axis, Z set on X axis, continue, and then we will click OK.
So you can see it was very easy to conduct correlational and regression analysis with SPSS. Thanks for viewing. Have a great day. Bye bye.